Hello, math friends. This is lesson 1.1. Write that at the top of the page in your math notebook. We're focusing on the real numbers today. We're going to start with using the real number line. Let's talk first about what real numbers are. Now, the numbers that are used most often in algebra are the real numbers. So let's talk about what classifies as a real number. Well, the whole numbers are part of the real numbers. Those are everything from 0 and the counting numbers on up. And their opposites, which of course takes us to the integers, all the whole numbers and their opposites. Rational numbers are numbers like fractions that can be written as a ratio of two integers. They can be written as decimals. When they are decimals, they will terminate or repeat. For example, like 3/4 can be written as 0.75, which terminates, and 1/3 can be written as 0.33333, and so on. And so those are the rational numbers. And then we have the irrational numbers, real numbers that aren't rational, like the square root of 2 and pi, because when they're written as decimals, they don't terminate and they don't repeat. They keep on going, but never in a repeating pattern, the irrational numbers. So the rationals and irrationals. Now, of course, the three dots in the list of the whole numbers and the integers above indicate that the list continues on without end. They don't just stop at 3, just so you know. Okay, now real numbers can be pictured as points on a real number line. And on a real number line, the numbers increase from left to right, and the point labeled 0 is the origin. So remember, as numbers get that way, they are getting larger. And of course, that would mean that the opposite direction, they would be getting smaller. Now, the graph of a number is the point on the number line that corresponds to a real number. For example, if I wanted to graph -3, I would put a point on -3. Look, I just graphed it. Drawing the point is called graphing or plotting the point. So I just graphed -3, or I plotted the point of -3. And a coordinate is the number that corresponds to a point on the number line. So -3 is the coordinate of the point that I just graphed. Now let's graph numbers on a number line. We're going to graph the real numbers, -4/3, the square root of 2, and 2.7. All right, so first of all, let's talk about -4/3. Now that can be written as a mixed number. That would be -1 and 1/3. And so -1 and 1/3 is going to be between -1 and -2. So as we're going away from 0, it would be about here. That is -4/3, or -1 and 1/3. Okay. Now the square root of 2 is, on a calculator, 1.4142135662, and so on. It keeps on going. It's an irrational number, but it's roughly about 1.4. So if we were going to graph the square root of 2, it would be somewhere just slightly less than 1.5. So probably about here. So square root of 2. And then, of course, the last one, 2.7. 2.7 is going to be somewhere between 2 and 3, closer to 3, so probably about here, 2.7. Okay, so graphing numbers on a number line, you just have to find where they are. Sometimes they have to be estimated, roughed in just a little bit as you graph them. Now, the reason that we graph numbers is so that we can order them, put them in order based on where they fall on the number line. Now, we use number lines to order the real numbers, and we use inequality symbols to order them. So remember, if you have this symbol here, that is less than. In this case, it would be all real numbers that are less than 2. Notice on the graph, we put a circle around 2, and everything less than that. All the real numbers less than 2. And of course, the next one, x is all real numbers greater than -2. So we find -2 on the graph, put a circle on it, and everything greater is to the right of that. And you'll notice that both of those have open circles because the open circles indicate either less than or greater than. Now, this next one, all real numbers less than or equal to -1. Notice how the inequality symbol is different. That's because when we graph it, we put a circle on it, and then everything that is less than that, but because it's or equal to, that circle also gets filled in on the number line. And likewise, x is greater than or equal to 0. So that would be all the real numbers that are greater than or equal to 0. So we find 0, put a circle there. Everything greater than that is to the right. And then we fill in the circle because it's or equal to, so it also includes 0. So when we fill in the circle, it includes the number that's there. So that's what the greater than or equal to or less than or equal to symbols mean. So now let's order some real numbers, shall we? It'll be fun. So first of all, let's look at -2 and 3. All right, we'll find -2 is here, and 3 is over here. So we can see from the graph that -2 is less than 3. Or we could say that 3 is greater than -2. You'll notice that the inequality symbol always points toward the larger, or always opens toward the larger number. All right, let's look at the next one, B, -1 and -3. Well, here's -1, and here's -3. Well, as you could see from the graph, -3 is less than -1, and so that would mean that -1 is also greater than -3. So you can see that inequalities can be written in two different ways. Now, how do we use ordering real numbers in real life? Well, let's have a look. Here we have some elevations of places. Here are elevations of 5 locations in Imperial Valley, California. And so let's see that Alamorio is at -135 feet, so it is 135 feet below sea level. Curlew, down here at the bottom, Curlew is at -93 feet, so that's 93 feet below sea level. Gieselman Lake is 162 feet below sea level. Moss is at -100, so that's 100 feet below sea level. And Orillia is -92 feet below sea level. All right, well, let's put these elevations in order from lowest to highest. So remember, on a number line, as we get farther away from 0, the smaller they are. So I'm going to put 0 here. And the one that's closest to 0 would be Orillia. That would be -92. Curlew is at -93. Moss is at -100. Alamorio would be -135. And Gieselman Lake is at -162. So if we put these in order from lowest to highest, then we would say that Gieselman Lake is the lowest, so that would be number 1 for the lowest. Next would be Alamorio, number 2. And then Moss would be number 3. Curlew at number 4. And Orillia at number 5, being the highest. And then the last question, which locations have elevations below negative 100 feet? Below negative 100. Well, there are only two that have elevations below negative 100, and we'll circle those. That would be Alamorio and Gieselman Lake. Those are both below negative 100 feet. Here, right? Because here is negative 100. And everything below that would be this direction. So that would include Gieselman Lake and Alamorio. Everything you wanted to know about real numbers and placing them in order. Hey, have a great day, folks. Don't forget to be awesome, and I will see you next time.